Okay, hi guys. So this is your tutorial 10, Mechanical Handling System for the course Building Science and Services 2. So there's a few questions in this tutorial, so let's get on with it. So the first question is asking you to discuss the rationale of adopting vertical transport system in a high-rise office. So why do you want to adopt vertical transportation system in a high-rise office? So first of all, is for the convenient movement of the occupant in the building. So if you have a very high building, as the name implied, the high-rise office building. So high as in 20 floor, 30 floor. If your work, working office or working space is located at 20 floor, it doesn't make sense to have your employee to walk up the staircase for 20 floor lah. So it will not be very efficient and productive for them to go up the floor to do their work and then come down for their lunch and then go up again for their work again. So it's more convenient to use to adopt this vertical transportation system as opposed to having the occupant walking up and down the staircase. So it's convenient and then it's also more efficient as opposed to going up and down lah, as opposed to us going up and down the staircase or even to transport goods. And because it's convenient and efficient, if you were to use it for a high-rise office building, then we are actually increasing the productivity of the office employee, so they do not need to move up and down the floor themselves, and then it reduces the transportation time. And then lastly, so is to provide a rapid and safe egress in case of fire or other emergency lah. So in emergency, when allowed, you have to use the vertical transport system to get out of the building lah. So this is not all the case lah. Usually as SOP for when there's a fire, you have to actually head to the fire escape staircase to get out of the building. So you're not actually supposed to use a lift to you are not supposed to take a lift to get out of the building lah. So just for your info lah. Okay, so next question. So is to ask you to list and elaborate the three main expectation of passenger lift. So the three main expectation is you want it to be safe, you want it to be comfortable, and you want the service time to be good. So safety is for safety when and then for safety and comfort, these two things. So when you have a passenger lift, you expect it to be safe and comfortable when you are using it. And then lastly, for the service, you expect the passenger lift to be available in a reasonable time. So you don't have to wait too long. So different types of building have different service time. So for a residential building, you can allow the occupant to wait a bit longer. But for commercial buildings such as an office building, you need to reduce your service time lah. So to reduce your service time, it might be a good idea to add more lift so that you can transport more people up and down the floor. Okay, so for the third question, it's asking you to explain the function of safety gear, counterweight, and buffer. So safety gear is there to in place in case anything happen to the cable. So they will kick in and stop the car lift from moving up and down. So even if the car lift is moving too fast, they will also kick in. So it's a safety gear to hold the lift in place. Okay, so a counterweight is a mass which is there to counterbalance the load of the lift car. So you do not want to put so much strain on your motor. You want to have a counterweight which is equals to about 40% of the car lift weight. So this is so that you do not need to tax on your motor too much. So instead of having the motor pulling or releasing the lift car whole weight, you have a counterweight to counter reduce the weight of this entire lift. So this is the idea behind why you want to have a counterweight lah. Okay, so at the end it will be a buffer. So this buffer is there to just counter the lift when they are traveling down. So when a lift is traveling down, the motor isn't actually doing much. So the motor is actually just releasing the weight of the lift. So as they are traveling down to the lowest floor, the lift might overshoot due to the might overshoot down over the designated floor due to gravity. So this buffer is there to counterweight and arrest them and make sure that they stay in the correct position if they were to over travel into the lift pit. So a buffer is something like a spring or a rubber. So just prevent them from sinking into the floor. Okay, so the next question is asking you to explain the common safety feature of an escalator. So we have our yellow line steps here. So this yellow line step is to enable the user to visually see the edges of the step. So if you see that your feet is very close to the step, you'll be able to keep your feet away from the edges. And then the second one is the brush deflector. So this brush deflector is there to ensure that you do not stand too close to the edge of the steps. So what will happen if you stand too close to this edge is that because this is a moving part, it's a moving step, so your shoe might get wedged in between the space there. So it is small, it's a small space, but it do happen. There's accident on this. That's why there's this brush deflector in place to prevent people from putting their feet too close to this edge. Okay, so the next one, which is not so obvious, is the angle of inclination of this panel. So it's to prevent kids from sliding down this handrail. Then the next one is the cone plate. So this is to prevent anything from going into the machine room. Then for the next one will be a flat step. So at the beginning and ending of the escalator, you need to have a flat step. So this is to provide a space or distance for the passenger to adjust their balance and adjust their feet. Okay, so lastly, the most important safety feature is this stop switch. So in case any accident happen, you will notice that there will be a stop switch at the end or at the beginning of the escalator. So people can easily reach and stop this escalator from continuing to operate if someone were to accidentally get stuck on the escalator. Okay, so number 5 is asking asking you to suggest a possible measure to conserve energy of escalator. So one of the way is to delay starting the escalator or travelator for as long as it is practical, and then to stop some of the escalator when convenient or after peak and normal working hours. So what we will see mostly is we use a auto startup program on the escalator. So this is the most common we see lah. So we don't see much of the people stopping or delaying the escalator. So for this one, it's a sensor type. So when people hop onto this escalator, then this escalator will start. So during the time when there's nobody using it, it will be entering into an ideal mode. Means it's just waiting to receive the signal for people to hop onto this escalator or travelator. And then once it senses that people are on the machine, then it will automatically start and pump in power to operate the escalator. So Lastly, it is to use a variable speed escalator and travelator. So out of all, the most recommended is to use a program to start a escalator or travelator lah. This way you'll be able to save a lot of money due to the escalator not needing to operate if there's nobody there. Okay, so question 6 is asking you to analyze the advantages and disadvantages of escalator. So advantages of escalator is that it's able to move a lot of people. It's very good to use to guide and circulate people. And then they can be turned off and be used as a staircase. And if needed, they can be installed outdoor. So one of the two key points for escalator is they are able to direct the flow of traffic. And the next thing is they are able to transport a lot of people across a single floor. But there is also advantages to the escalator. So if you're not using it, you are wasting the money lah. And then because it's a moving staircase up and down a floor, so the possibility of injury is very high to children or elder or when it's stopped. Okay, so question 7 is asking to compare and contrast the difference between lift and escalator. So in terms of speed, escalator are slower and elevator are faster. So if you were to, in terms of why is it slower, so if you were to compare that taking a escalator and an elevator going up and down multiple floor, so escalator is very good at moving a single floor, but if you were to go up more and more floor, then elevator will win against escalator lah. Okay, so the next is the loading capability. So escalator is ideal if you want to move in between one floor. So it's able to carry a lot of people. But for lift, you can only tuck in as much people as the weight allowed. So, but one thing good about lift is they are able to travel as a steep as what I mentioned in the speed factors. They are able to travel very fast for different multiple floor. Okay, so for electricity consumption, so escalator eat a lot of energy because they are operating continuously. But then, whereas elevator consume only electricity when in operation. Okay, so the next question. So explain the three main functions of a baggage handling system. So in an airport, so the function of a BHS, the baggage handling system, is to move the bag from check-in area to departure gate. And then you have to move the gate, you have to move the bag from one gate to another during transfer. And you have to move the bag from arrival gate to the baggage claim area. So basically conveyor is pretty standard. First off, you need to find out what is the capacity of a conveyor to convey the load, what type of belt you'll be using, type of driving pulley, type of idler and spacing, and the motor power. Okay, so this is the calculation question. So you have a few formula that you need to remember, or since it's a open book class, so you can refer to the formula. It won't be provided. So the first formula is this RTT, and then the second is INT, and the next one is HC, so the handling capacity. So you have a group of 4 lift car designed to serve 8 floors in an office building with a 3.2 meter floor height. So it is required that the handling capacity is 80% per in 5 minutes. So this is a requirement. The car has a rated capacity of 10%, which is this is a cc, and then the rated speed of 2.5 velocity, and the performance time of 10 seconds. So this is the time. So it's asking you to calculate the interval time, totaling and total handling capacity, and subsequent comment on the performance of this lift system. So they have already give you the requirement, which is 80% in 5 minutes. So the subsequent comment is you have to comment on this. Is all this specification given able to handle up to 80% in 5 minutes? So this is the first step. HC, the handling capacity required is 80% in 5 minutes from the info above. So you know that n is equals to 8, which is the number of floors. The df is equals to 3.2, which is the floor height. The cc equals to 10, which is the person. And the v is the velocity is 2.5 meter per second. The performance time is 10 seconds. And the L is equals to 4. So this is the number of lift cars. And TP is the transfer time, 1.2 seconds. So with all this information, you'll be able to find the P, H, and S. So this we will be able to get from the table F1. And then you'll be able to find out that TB equals to DF over V. So you'll be able to find that TB is equals to 1.28. You sub all this information into this first equation. So your return interval your RTT will be 93.34 seconds. So next you want to find your interval time. So this is interval time had to be equals to RTT divided by L, which you will be getting 23.34 seconds. So for an office building, this is considered good because it's less than 30 seconds. So table 3.9 will be provided to you, which you'll be able to compare is it good or not. Then lastly, you have HC equals to this formula. You need to use this formula to check out how much handling capacity is there. So we found out that the handling capacity is 100 plus, which is more than 80. So for the comment, you just put an OK there. That'll be good enough. So this is the table F.1. So from this, to extract the information, you know that your P is equals to 8. So you need to find your P is equals to 8, which is here. So then you have your number of floor. So how many number of floor? There's 8 floors. So 8 and 10, 7.5. Your H is 7.5 and your S is 5.3. So this is how you get the H and S from the table F.1. So you refer to your number of floor here and what is your CC. So your P you don't actually have to calculate, you can actually extract it from this table F.1, but you just need to indicate that this is from table F.1. Okay, so next question. A travelator was designed with 1000 millimeter wide, so it's a 1 passenger per step, a speed of 0.5 meter per second, and 400 mm tread. So this passenger traffic at this travelator will be increased to 5,250 person per hour. So you have to comment whether or not the design is able to fulfill the passenger traffic demand. So this is a new demand, and this is all the information that you are being given. So what you know is that v, the velocity is 0.5 meter per second, and your length is 0.4 meter, and your p, which is a passenger per step, is 1. So this will be given to you lah, the passenger per step. So it's required that the travelator is able to handle up to 5,250 person per hour. Because this is a travelator, so you do not have any angle. If it's an escalator, then you need to use the formula lah. Then you need to put in the cost angle into your formula. So this is derived from the formula in which you can find in your lecture. Okay, so you just put in the information. So this is a fixed value multiplied by the P multiplied by the velocity, and then divided by the track. So you're actually getting 4,500 person per hour, which is less than what the required. So you have to comment that this design currently is not able to fulfill the future passenger traffic demand. Okay, so because this question did not ask you to do, but if the question did ask you to fulfill, if there's additional instruction, then you have to fulfill lah. But in this case, the question did not ask you to how you can fulfill the passenger traffic demand. So actually you don't have to do it lah. So it's just asking you to comment, is it able to fulfill or not? So once you did until here, it will be done lah. So if the question is asking you to, if the question has additional instruction where it says that if the current design cannot fulfill the future needs of the passenger traffic demand, so it's asking you to address the issue, then you have to do these additional steps, which in this case you can just increase the speed of the travelator lah. Okay, so the next question, this is the same as the lift, additional question for you to practice on. So you've been given all this information: n equals to 10, df 3.3, cc 13, velocity 1.6, the time is 10 seconds, and then your L is equals to, okay, P, what's this? So your L is not given. And your TP is equals to 1.2. Okay, so you're not given an office building with 3.3 meter. Floor height is designed with a lift system serving 10 floor. So you're not given an L. But you have an INT which is required, which is 30 seconds. And your HC is required to be 100 person in 5 minutes. So as usual, you find out the information from table F.1, and you have to put in and you have to use this first formula, which is the RTT. So you'll get a value from it, which is 125 seconds. And then because you know RTT, you know this formula. So this formula is a derivation of this INT equals to RTT divided by L. You're actually able to find out the total number of minimum car required to achieve the interval, to achieve your interval time. So with that, you find out that the number of car minimum required to hit the RTT is 4.17. So you are to round up the number lah to provide 5 lift car. So from there, you have to use it again to to get the INT, to get the interval time, which is 25 seconds. So they give a required interval time of 30 seconds. You have to use it here. So because this INT is less than 30 seconds, so you already check out this, which is okay. And then lastly you have to find out the total handling capacity. So you put in the formula, you find out that it's about 124% in 5 minutes, which is more than 100. So this design is okay for your lift. Okay, so the next question, analyze the benefit of machine roomless MRL over the conventional machine room lift. So the difference and benefit between the MRL and the MR is that you do not waste your space, and then you use less energy and is slightly lower cost than the other elevators. Okay, so the next question is to state the difference of passenger lift and good lift. So we have a very buff guy, which is a good lift, and a very skinny guy, which is a passenger lift. So basically, good lift is a lift that is designed to carry a very high load, and a passenger lift is to carry a passenger lah. So passenger is very light as opposed to goods. So goods can weigh very heavily, up to 2 to 3 ton, depending on what sort of load you are loading onto the lift. So because you are for a good lift, for the speed factor, because you're loading a very heavy load. So considering the Newton law, if you were to move something very fast, then if you want to stop it, you need an opposite force to stop it. So that's why they have to operate at a restricted speed. So it will provide a minimum disturbance to the movement of the goods. So for passenger speed, you're able to travel faster because us people inside the lift, we are able to balance ourselves, but the goods are not able to balance ourselves. So the operation and design of a good lift. So for a goods lift, you may have a manual operated door, and the interior are often rugged, so it's a clean finish, so they don't do any finishes or additional interior design for the goods lift. But for passenger lift, normally they will have a very nice interior, and you don't have to operate a lot of stuff. Most of the stuff will be automatic. Okay, so that's about it. So only three stuff, which is the loading capability, the speed, and the operation and design. So these are the three stuff which the good lift will different between the passenger lift. Okay, so next question is to state the difference of hydraulic and traction. So a hydraulic lift is a lift which use a pump to work against the gravity to push the lift car up. So when the car is descending, it's essentially just releasing the energy and letting the car descend on its own weight. So a traction lift is what you have been studying and seeing this whole time. So it's a lift with a counterweight and a motor to move the lift up. So in terms of speed, traction lift can go faster than hydraulic lift. So hydraulic lift can really go very fast, and the speed tend to peak at around 1 meter per second. So this is due to the way hydraulic works. So you are essentially using a pump to push the car up. So you won't be able to, you are using liquid pressure to push the car up. So you aren't really able to do it very, very quickly. So in terms of price, hydraulic is actually a bit cheaper, and traction is more expensive. So traction, you have a lot of motor. You have motor running the to as a powerhouse there to move your lift. But in hydraulic, you're just having a pump. So there's price difference between a pump and a motor lah. So a motor usually costs more expensive, hence why a traction lift is more expensive. So lastly, space. So traction lift usually previously takes more space, but now with the introduction of this machine roomless lift, they are about the same with hydraulic lift, but they will take a bit more space on the top of the lift. For hydraulic lift, it's usually suitable for place where you don't have a restriction of you have a restriction of space, in a place where you have restriction of space. So hydraulic lift is requires less service area for their component as opposed to traction lift. Operation wise, hydraulic lift is a lift that get power through an electronic pump. So this will in turn transmit hydraulic fuel to a jack. So this jack is what push the lift up and down a floor. So for traction, we are using a shaft and rope. So you have a counterweight to balance it and a motor to drive the lift up and down. So essentially this is what's the difference between hydraulic and traction lift. Okay, so that's all for your tutorial 10. Hope you guys understand.